two key pieces of information that we have to characterize. And indeed, that was the component shown in blue here. Number one is the network topology. So what's the structure of the network on a logical level, putting aside the issue of kind of spatial mapping. And the second thing is spatial and visual layouts. Okay, so it's how is it going to appear, and how are the people within the network going to be arranged in space? Okay, so we're going to be looking at both of these within these lectures. Generally speaking, we're going to have an interplay between nodes' locations and nodes' connections. Okay, so spatial layouts are going to determine where the nodes appear in space and on the screen, and the network type is going to determine who is connected to who. Okay, so we're specifying both of these. For the most part, these characteristics are determined independently. Okay, but you'll see there's two types of networks, namely distance-based networks. Excuse me, three types: distance-based and a type of network that where we have clustered items being shown together. Excuse me, it is just two types: clustered items shown together, sort of arranged to appear close to each other, to be located close to each other if they're connected, and then distance-based connections. So for those two types, they're coupled together in important ways.
So this is only about two-dimensional models?
This is two-dimensional models. There are three-dimensional models that I'm not going to get into here. Okay. Here we're dealing with 2D because it's a pretty good approximation to geographic space, particularly. But 3D is also possible with AnyLogic.
So can you have networks of agents connected to things that are in space? So they might be separated by large distance, but you still can communicate to the same or something. Based on certain, if they have certain characteristics.
Let me see if I can get what you're asking, and if I don't, help me understand better. So if you're asking, can you have agents that are situated far apart from each other in space,
right,
but logically are still connected?
Yeah.
Yes, absolutely. And in fact, we'll see lots of examples of that today. You can also have cases where those connections are contingent upon them being located close in space, right? So you can have either one. Great question.
Could it be, so for instance, if you're trying to model like an organization,
yeah,
could the network be based on, not on distance, but on, say, where in the organization the person is?
Yeah, absolutely. And for a lot of those sort of questions, what you're going to be wanting to think about is one of two things: either a network that's hierarchical, where you have something like different levels, perhaps here. Maybe these are different project teams for engineers or something. And you'll have perhaps even a caveman network where everyone's connected to everyone at that level. But you might have a manager, and the manager would relate to all these, but would have connections with others at their level, and you might have something along these lines, and then on it goes upwards, for example. And you could do that. Some of that can be done through built-in network types with a hierarchical model. We'll see in another lecture how we build up hierarchical models. So in other words, where this might be, I've commented on this before, this might be project teams, and these are different divisions in a company, and these are, and the whole thing is in one company. Or these might be individual animals within a farm, and the farms are located within some state and within some country. So those hierarchical models are readily built up within AnyLogic, and then you just use built-in network types to connect them. The other possibility is you can build up networks in a custom fashion using some of the mechanisms we'll see in the second part of today's lecture. Okay. In other words, you can have a bit of code which builds up a custom network structure per your interests, or reads a file in or from a database and sets up a network accordingly. Okay. So generally speaking, it's faster if you can build atop existing built-in networks and maybe do them in a hierarchical way. But if that's not possible for your application, you might have some custom code to build up the network. Okay, it's a great question. Yeah.
Brief question. You just mentioned caveman network. Just very briefly, what's that?
Yeah. So it's a network where everyone is connected with everyone else.
Like caveman? Is that the idea? Like, what's the connection?
It's a good question, and having studied paleontology, it's not immediately obvious to me. I believe that the analogy is probably that, and the belief was that that early hominids exhibited limited variability in their sort of connection repertoire, and you would have a small clan or family living together, say in a cave, and they would all know each other, and there was no sort of hierarchy that limited access to one or other of the members. Now, of course, what that belies is the fact that these caves are presumably distributed in space, and different foraging subgroups would encounter each other, but wouldn't encounter someone who's 1,000 miles off, and so on. But that's the term, for whatever reason, that's used for a fully connected network, as we call it, a completely connected network. And I think in mathematics it's called K sub n. So like a K3 would be a completely connected, threesome, and a K4 would be a completely connected thing like that. That would be K4. This would be K3, and so on. So that's a totally connected network. K probably being the equivalent of a hard C in German. So anyway. Caveman network, and we'll see several other types of networks here that AnyLogic supports. Okay, so I've just been distinguishing here between two sets of issues that we're going to be dealing with today. One is network topology, the choice of who is connected with whom, purely a logical matter. The other is layout, which has to do with where people appear physically in space, in a 2D space, and by extension, where they appear on the screen, okay, visually. Those being sort of direct mappings of one another, where they are in space and where they appear on the screen. And we're going to see that they are distinct attributes, but they're coupled. And particularly, they're coupled for two types of networks, okay? So, let's go. I asked people if you could call up your the network we've been or the model we've been building up, to which we added infection transmission or contagion of one sort or another last time. If you are having difficulties with that model, or if you prefer to sort of start from a clean model, you could alternatively open up the example model I provided for the class called Minimalist SIR Network ABM. Okay. Slight differences between the two, but either will be fine for our discussion today. So I'd like you, within that model,